Hello, nice to see you online, and this is a special period of time. I'm very glad to share some opinions about the knowledge construction. And my title of presentation is on the construction of chemistry knowledge from a perspective of technical terms. Here is the outline. It mainly consists of 5 parts: introduction, literature review, theoretical framework, research design, and last comes conclusion. Let's look at the first part, introduction. Now, we can see that it is an era of knowledge economy, a knowledge industry, in which the knowledge is just like goods or commodities, which can be exchanged. For example, in the field of education, etc. That is, knowledge is very important and is part of our life. In contrast with this fact is that we usually ignore or distort knowledge, and such phenomenon is covered by the term knowledge blindness, suggested by Merton. According to him, knowledge blindness is caused by 2 factors. One is subjectivist doxa. Under such dictum, knowledge is a process of learning. And another factor is called constructivist relativism. It believes that knowledge is reduced to relations of power in society. At the same time, we can find knowledge have a close relationship with education, and textbooks are the main carriers of knowledge. But according to Myers, the studies of textbooks are usually marginalized or degraded as commercial programs with no relationship to research. And that's the main reason why I study chemistry knowledge construction via textbooks. Here comes the second part, literature review. And according to the study purposes, Moore in 2002 divided these studies into 2 general types, pedagogical and epistemological. In terms of pedagogical, these studies are used to help university students, especially second language students, improve learning via examining linguistic difficulties for meeting the required language demands of textbooks. And such researchers include Love, Allison et al., Martin, Veal, and etc. In terms of epistemological, such studies are dealt with knowledge construction from a linguistic perspective in textbooks, and often involves comparison between different academic genres. And in general, we can say studies for the former are more than those for the latter. By extension, such tendency is more obvious within systemic functional linguistics, represented by the Sydney School, which is devoted to the study of textbooks for education. A few studies we can find about chemistry knowledge. For example, Srinivas 2010. But his focus is on clause complexings in the construction of chemistry knowledge. Also, we can find Yang take metafunctional perspective to study chemistry knowledge. Among these studies, we can find less attention has paid to technical terms in the construction of chemistry knowledge, and usually they are conducted from only one perspective, for example, systemic functional linguistics. And meanwhile, we can see that Without technical terms, there is no knowledge. In other words, technical terms are a fundamental part of knowledge construction. On this basis, I want to explore chemistry knowledge construction within the combination of systemic functional linguistics and LCT. The third part concerned with theoretical framework. And the first is the functional typology of technical terms. In 1999, Halleck and Matheson divided participants into two subsystems. One is macro and simple. The other is thin and quality. Inspired by this typology, I make a workable categorization of chemical technical terms. And in this categorization, also the distinction between macro and simple is retained. But in terms of the semantic types, I add activity and semantic. The first distinction is made according to whether the generation of technical terms involves grammatical metaphors or not. Macro types, its generation involves grammatical metaphor, but simple ones does not. Thin type of technical term. Here, it refers to chemical entities or phenomena, for example, acid. And activity type is used to refer to chemical processes and changes, example, beta emission. And quality types are used to represent properties of chemical world, such as density, volatile. And the last time, semantic type is used to refer to locations, source, ideas, or principles, for instance, band theory. In terms of semantic density, I believe it is a way to measure the degrees of affordance of technical terms in constructing knowledge. What is semantic density? And according to Merton, it can be described as degree of meaning condensation within a symbol or word. In order to bridge the gap between semantic density of LCT and its practical issues, for example here, linguistic issues, a translating device was proposed by Merton and Doran, which can be shown below. The first is wording tool for epistemic semantic density. Because here, I just focus on the chemical technical terms, therefore, this part I will give special attention. In terms of technical terms, according to Merton and Doran, it consists of conglomerate terms and compact terms. Conglomerate terms are those that comprise multiple distinct parts that each possess a technical meaning. For example, biochemistry. Bio possesses a part of meaning. It means related with something living. And chemistry means a branch of subject. As a whole, biochemistry has a technical meaning which refers to one sub-branch of chemistry. And compact terms are those that comprise a single part with a single technical meaning, for instance, chemistry. Following the decline of delicacy, and conglomerate technical terms can be divided into element subtypes and property subtypes. In terms of element subtypes, they refer to an item or entity, a thing of some kind. For instance, biochemistry. And for property types, they are used to refer to quality or action linked with elements. For example, endothermic. Endo means in, and thermic means having to do with hot springs. And as a whole, it means relating with the process of heat absorption. Compact terms can also be analyzed into elementary elements types and property types. Another word grouping tool is tabulated below. And according to Meta and Doran, this type consists of 3 subtypes: embedded, categorized, located. We can look some examples to illustrate them. Embedded, for example, the book I read yesterday. In fact, this type is realized by relative clauses. And categorized, for example, English books. And English in this group is used to classify or categorize books. And located, for example, books in the desk. And we can find from embedded to categorized to located, their meanings decrease. And at the same time, we can say that their ESD, epistemic semantic density, decrease. Combining the 2 translating devices, I propose the operational system for measuring the affordance of technical terms of chemistry for knowledge construction. Here, please note that I add empty set. It symbolizes that without this symbolizes without any modifying elements. Research design. First, it is about research questions. I pose 3 questions. That is, from a perspective of technical terms, what kinds of knowledge can be constructed? The second, how to describe the degrees of contribution of technical terms in knowledge construction. Third, what's the relationship of chemistry knowledge construction between high school level and university level? Research data. Here is research data. You can see the basic information about them. In terms of university level, I choose 2 textbooks, Chemistry, the Central Science, and Chemistry. Also, in the same way, in terms of high school level, I choose 2 textbooks, Chemistry, Concepts and Applications, and Modern Chemistry. In terms of the procedures for data processing, in answering the first question, and what kinds of knowledge can be constructed, all total number of technical terms for each level is calculated, and then percentage of the number of each semantic subtype of technical terms relative to the total number of them for each level is gained. But in answer to the third question, the comparison between the different levels as a way of normalizing the number so as to compare the 2 levels more scientifically. In each book of each level, we choose the first 3 chapters, and this means that for each level, we choose 6 chapters, and then we analyze the total number of the clauses and technical terms within the chosen data for each level, calculating the percentage of each subtype of technical terms with a certain degree of ESD in the chosen data relative to the total number of the clauses. Lastly, we use the percentages of subtypes of technical terms with certain degrees of ESD to compare the two levels of knowledge. After that, the likelihood between the two groups of data and are calculated to judge whether to have a significant difference. Here, the first question. In terms of the semantic types of chemistry knowledge construction, and through analyzing the data, we can find such result showing in the table. We can find in both high school and university, there are 4 semantic types which can be identified. That is thing, activity, quality, and semantic. Also, we can find in both levels, from thing to activity to quality and to semantic, we can find decreasing tendency. Also, in terms of the 2 subtypes, activity and quality, we can find the MO. MO is short for macro type. That means that these technical terms originally involve the grammatical metaphors. We can find macro types occupy the highest percentage in these 2 subtypes. Therefore, we can gain the 4 brief conclusions. Firstly, in both levels, the technical terms construct 4 different kinds of meanings, namely thing, activity, quality, and semantic. Secondly, through R, the correlation value of them is 0.99, indicating that the 2 groups of data are correlated. It can be found that from thing to activity to quality to semantic, as mentioned above, there is a descending tendency. And thirdly, in both levels, thing type of technical terms occupy the highest percentage, which indicates that in the domain of technical terms, they are thing-oriented. In quality and activity types of both levels, macro subtypes occupy the highest percentage, suggesting these types are originally generated via grammatical metaphors, and gain the potential for categorizing nominal groups. In terms of degrees of contribution of technical terms to chemistry knowledge construction, within the same semantic subtype of technical terms, for example, activity, energy, and acid, whether do they possess the same affordance for constructing knowledge, indicated by degree of ESD? And this is the question solved in this section. Following the operational system for measuring the affordance of technical terms of chemistry for knowledge construction, each subtype of technical terms can be identified. That is, type 1, empty set compact element type; type 2, empty set compact property; type 3, empty conglomerate element subelement; type 4, empty set conglomerate property; type 5, type 6, type 7, and type 8. We can look 2 examples to illustrate type 1 and type 2 because of the limitation time. And type 1, for type 1, for example, acid, we can find such type only consists of one single part with a technical meaning. Type 2, we can look the example density. This instance is still one single part with a technical meaning, but compared with acid, density presupposes a carrier of it. but it can activate more semantic relations than ACID. Then we can see that type 2 is greater than type 1 in terms of semantic epistemic semantic density. Following that way, we can gain two lines of ESD according to the descending order. One is type 4 is greater than type 3, greater than type 2, greater than type 1. Another line is type 8 is greater than type 7, greater than type 6, and greater than type 5. Here, please note that we find two special types. Type 9 categorize compositional element, like absolute zero, and type 10 categorize compositional property, such as heat capacity. And here, please note the bolded parts, zero and capacity. They themselves are not technical terms, but as a whole, absolute zero or heat capacity, they can be qualified as technical terms. And common to all instances above is that the head parts themselves are not technical terms, but as a whole are. This means that they as a whole are equivalent to amplicet conglomerate element and amplicet conglomerate property, respectively. The difference is the component part is bound or free. Thus, we can modify the two lines of ESD according to the descending order. Lastly, let's compare the chemical knowledge construction between high school level and university level. The first chapters of each textbook are analyzed. The total number of clauses for high school is 2,962. The total number of clauses for the university level is 3,478. Using R, we analyze their difference and correlation. The p-value of difference is 0.9698, greater than 0.05. This suggests that at the global level, there is no significant difference between high school and university in terms of chemical knowledge construction from the perspective of chemical technical terms. In order to find whether to have a local difference, the log likelihood and effect size between the two levels is calculated. But results show that there is no local difference between the two levels. A combination of 1 and 2 shows that, quantitatively speaking, chemical technical terms do not cause extremely distinct differences for chemistry knowledge construction between high school level and university. Of particular note is that no quantitative difference does not mean the insignificance of technical terms for knowledge construction. On the contrary, they construct different kinds of knowledge. Neither does it mean that the effects of the contribution to chemistry knowledge between different levels are functionally or qualitatively equivalent. As we just gained two lines of ESD according to the descending order, the specific relation is unclear. For example, type 3 is more complex than type 1, but the accurate value of the complexity difference is vague. Here is a conclusion part. Firstly, by reference to the functional typology of technical terms, it can be found that technical terms construct four kinds of knowledge. That is thing, concerned with instruments and substances; activity, concerned with chemical processes or changes; quality, properties linked with thing activity; and semantic, which is referring to principles, abstraction ideas. And secondly, following the framework for measuring the degree of ESD for technical terms, two lines can be identified. That is, and this symbol means greater than. And thirdly, by comparing the relationship of chemical knowledge construction from the perspective of technical terms, no significant differences between high school and university are discerned. But this doesn't mean that the contributions of technical terms between the two levels are functionally equivalent, at least before the identification of an accurate relationship between different subtypes of technical terms with different degrees of ESD. Thank you.